This is Mr. Hanna with Lesson 5.4, Solving Compound Inequalities, which is on page 304 to 307. Compound inequalities are two inequalities that are combined. You have two types, something like this, negative 3 less than x less than 4, which reads, and sometimes you may see it written like this, and you'll have to convert back and forth, negative 3 less than x and x less than 4. With an AND statement, both of these statements must be true at the same time. When you graph them, negative 3 less than x would be x greater than negative 3, which would go like this. Yes, it would go past the 4. X less than 4 would be a circle on 4, and it would go past the negative 3 like this. But since both have to be true, you don't draw the parts where they don't overlap. An OR statement would read like this, x less than negative 5 or x greater than 2. These, only one of them has to be true. Your book calls this a union because we're adding these two parts together on the same graph. This is called an intersection because it's where they overlap on the AND statement. To solve any compound inequality, you split up the compound and you do each side. With an AND, you graph where they overlap. With an OR, you graph both parts. So the first example I have, y minus 3 greater than or equal to negative 11, and y minus 3 less than or equal to negative 8. Could also be written as minus 11 less than or equal to y minus 3 less than or equal to minus 8. Notice these things on an AND statement will always point in the same direction if you've written it like this. They'll either both point to the left or both point to the right. And they don't have to be the same inequality. This could be less than or equal to, this could be less than. Y minus 3, I add 3 to both sides. I get y is greater than negative 8. And y minus 3, I add 3 to both sides. Y is less than or equal to negative 5. Now, I would graph this, y is greater than negative 8. I would put a dot, because it's got the line underneath, greater than or equal to. Put a dot on negative 8. And it would keep going to the right. But if I go past this minus 5, then both aren't true, so I don't write the overlap. Same thing over here. I would start at minus 5, put a dot on it, go to the left. And it does, this part does keep going after negative 8. But after negative 8, both are not true, so you only graph the part where both are true. Now, if you have an inequality written in this combined form like this, which is fine, when you solve that, notice what I did. I put the plus 3. I got to get rid of this plus 3, or this minus 3. So I add 3 to every side because there's the middle. I got to add it here to cancel this out. I got to add it over here because this is one inequality. And then I have to add it over here because this is another inequality. Now, if we're solving OR statements, you do each part separately, and then you graph both parts. So if I have a plus 1 is less than 4, simple one-step inequality, subtract 1 from both sides. I get a is less than 3. Or a minus 1 greater than or equal to 3. Notice these don't have to be the same. I add 1 to both sides. I get a is greater than or equal to 4. So then I graph this piece. That's the 3 with a circle on it and the arrow going to the left. And I graph this piece. That's the 4 with a dot on it and the arrow going to the right. Now, if you go back to that first type where we had an AND statement and you try to graph them, but you get a graph that winds up looking like this, where they don't overlap at all, then both are not true. And because both have to be true, the answer is no solution. Your homework is page 306, 2 through 30 even. Actually, it's